all of you. In this slideshow or video, we shall be discussing the concepts in testing of hypothesis. First of all, we will speak about the alpha. Alpha has very many connotations. It is the area of the critical region. Once we have a graph showing us the acceptance region and the critical region, it is the area of the critical region. It gives us an idea of the level of significance to use while testing a hypothesis. It is the probability of type 1 error. Just consider the graph. This is the normal curve, the typical inverted bell structure, symmetric about the y-axis. Y-axis is not shown here, could be assumed. And here you can see the level of significance is 0.1. Alpha is 0.1. There are two white regions under the graph. Two together put alpha at 0.1, each of 0.05 area. And these are the critical regions. Acceptance region is 0.9. If computed Z falls here, we accept H0. Another similar graph here, alpha is 0.05, and if you see the two white portions on either side, that they form the critical region, a total alpha of 0.05. 0.95 is the area of the acceptance region, and if computed Z falls here, we accept H0. Once again, a similar kind of graph, that is your alpha is 0.05, suppose. Okay, so the two areas will be 0.025, and 1 minus alpha will be the area of the region in the center, that is the acceptance region. Now we come to another part of this particular video, and that is how do you go about testing a null hypothesis, and we will discuss it in the form of a very primer kind of discussion. You have hypothesis. Hypothesis is a kind of assumption, and we use results from the primary data to test whether our assumption is true or not. Thus, we have the assumption which is formulated in the form of the null hypothesis, or H0, and H1 is the alternative hypothesis. We specify H0 and H1. We select our level of significance. We find the tabulated or the critical value of Z, and accordingly we also find the computed value of Z and accept or reject H0 depending on whether the computed value of Z falls in the acceptance area or the critical region. Now in this particular case, I must tell you that it is a primer in testing of hypothesis, so we are thinking only of the Z test, or the test of the equality of mean to a particular value for a large sample only. H0 and H1, they are mutually exclusive. They cannot both be true together. They are completely exhaustive. That is, two together, they exhaust all the possibilities. Actually, a null hypothesis is true, but we end up rejecting it. That is a type 1 error. And alpha is the probability of type 1 error. Now, if actually the null hypothesis is false and we accept it, then we commit a type 2 error. Beta is the probability of type 2 error. The graph shows us some kind of a relationship between alpha and beta, though it's not very clear. So, but we can understand that if the probability of type 2 error increases, accordingly the probability of type 1 error will get reduced. Alpha and beta, if you realize, are conditional probabilities. That is, alpha is probability that we have rejected H0 given that H0 is actually true. Beta is probability we accept H0 given that H0 is actually. How we speak p-value. If you do testing of hypothesis using SPSS or any such package, you are going to talk about the p-value. What exactly? The p-value for a two-tailed hypothesis is the area on both sides of the computed z, that is the area on either side of plus or minus computed z. So in a single-tailed hypothesis, if it is left-tailed, it is the area on the tail side beyond the computed z. Right-tailed hypothesis, again area on the tail side beyond the computed z. So thus if H naught has to be accepted, the p-value must exceed alpha.